if there was ancient civilizations, ancient cultures, and they were technologically advanced, let's not assume that they looked anything like we do. I mean, we built a whole civilization based on fossil fuels. Is that the only way to build a civilization? And I think the answer is no, it's not. I'm looking at our fossil fuel use as a very effective and powerful interim transitionary phase. But I think that there are technologies on the horizon that could be recoveries of things that people in the past already knew about. And it's kind of like when a lot of the archaeologists are looking into deep history, which to me goes back beyond the Holocene. The Holocene is the last roughly 11,000 years, post-Ice Age. But when we're looking into deep history, we're really looking into a mirror. We're looking for something that looks like us, and it may not look like us.
How have you been?
Oh, I've been mostly good, traveling a lot and getting weary from being on the road. So I've been back about 2 weeks now and just kind of, it takes me a week. When I spend a month on the road, it takes me a week to recover.
I'm the same way, whether it's like just the exhaustion of the travel, the work that you did, or, being away from the norm. So I feel the same. I'm catching up on some sleep myself.
I'm not quite as adept at roughing it as I used to be. I could sleep, anywhere pretty much, under a picnic table during a rainstorm, which I actually did one time when I was stuck out on the Olympic Peninsula. But I can't do that like I used to.
Cool. Where were you at in the last few weeks?
Well, I was out in Washington State, Eastern Washington, northern Idaho, and northern Oregon, that area, along the Columbia River mainly. I was taking a group of people interested in learning about the gigantic mega floods that happened during the end of the last ice age.
It's like one thing when you look at a river, but then when you pull really far out and look at the topography and the general formation of the surface of the earth, it's like, oh wow, it really comes into view how that could be, as well as, of course, those specific examples you gave of the way that the rocks lay and different things that give you the indication of the flow of what was coming through. So was there anything new that you saw out there? What did you see?
My colleague, Brad Young, did a fantastic job of getting us into places that are not ordinarily accessible to tourists and the public, like private. Like one of the places we went into is near Lewiston, Idaho, and which is right at the confluence. It's on the Snake River, pretty much right where it emerges from Hell's Canyon. And Hell's Canyon, you may know, that's the deepest canyon in North America. It's actually deeper than Grand Canyon. Part of the reason it's so deep is because there was this gigantic mega flood that flowed through there at about 40 million cubic feet per second during the end of the last ice age, and we call it the Bonneville flood. And I don't know if we looked at any slides of that. I have some great aerial slides where you can see how enormous the channel was left behind by this particular flood. Well, in the last episode that I did with you, we talked about the Missoula flood a lot. We call it the Missoula flood after the town of Missoula, because where the town of Missoula now is, that was under about 1,000 feet of water during the peak of this flood. Well, there's a place near Lewiston, Idaho, called Tammany Bar. And there's a creek that comes in from the east, meets the Snake not long after the Snake River, not long after it emerges from Hell's Canyon. And there is a huge gravel bar right there. Now, if you go out and you walk along a creek or a river, what you find is that in the curves of the water flow, the bars are always built on the inside of the meander, it's called. Why is that? Well, because when you look at water flow, think of all the little water molecules are all wanting to be be aligned with each other. So if you take a cross section of a river or a creek, the water is flowing, but if it's a straight channel with smooth sides, all the water will be pretty much flowing at the same velocity. But if you start putting bends in there, or you make it wider or narrower, then the water flow is going to be changing velocity in order to, because what it's trying to do is all those little molecules want to stay next to each other. So you're going around a curve, the inside of well, you would know this well from racing.
Yeah.
Right? If you're on the outside of the bend,
faster.
You got to go fast.
faster to keep up.
That's exactly it. So what
So
happens?
it keeps you eroding and moving out. So you would never want to build there. You'd have to be on the inside because that's where it moves the slowest and is the most constant.
You have exactly got the concept.
Yeah.
So what it does is it builds gravel bars or sandbars on the inside and it erodes on the outside.
The holiday season is starting, and it's easy to fall on routine this time of year. That's why I've relied on drinking AG1 for the past 2 years. I ditched my other supplements for AG1, and I don't plan on stopping anytime soon. AG1 especially helps me when I'm traveling and need an easy way to support my health. With added benefits of probiotics, prebiotics, and adaptogens, AG1 can help combat the stress of holiday schedules while helping your digestion and supporting your energy. What I love about AG1 is that they come in individual packs. I can take them on the go, which makes it so easy for not only my work, but the holiday travels I have coming up. I've noticed since I started taking AG1 that my gut health is so much better. My stomach is flatter, less bloated, and I can eat basically whatever I want. Before I go ahead and put coffee on top of it, I go ahead and use AG1 first. So this new year, try AG1 for yourself. It's the perfect time to start a new healthy habit. And that's why I've been partnering with AG1 for so long. And AG1 is offering new subscribers a free $76 gift when you sign up. You'll get a welcome kit, a bottle of D3K2, and 5 free travel packs in your first box. So make sure you check out drinkag1.com/prettyintense to get this offer. That's drinkag1.com/prettyintense to start your new year on a healthier note.
When water is moving, there's two things that affect the velocity. And the velocity in turn is related to the amount of shear forces that are exerted on the channel walls and bottom. Mm-hmm. That in turn leads to how much erosion takes place. Mm-hmm. So there's a whole interplay of factors here. One is the velocity of the water. The other is how coherent is the channel. If it's hard bedrock, there's going to be little erosion. Right. If it's an unconsolidated material, there'll be a lot of erosion, right? Mm-hmm. But what happens is that the water sweeps around in that curve and it builds a bar, or it could be a sandbar, but in the flood features that I look at, oftentimes they're boulders because the flow of the water, when you're looking at 40 or 50 or 100 million cubic feet per second and even more, the sediment that's entrained in that flow can be enormous. Yeah. It can be boulders. It can be, 1,000-ton boulders and bigger. Then you look at the gravel bar or the boulder bar, and what happens is there typically is the deposit of the material is going to be on the upstream side. The larger stuff is on the upstream side. The smaller stuff is on the downstream side, right? If we think of this, imagine that we've got a channel and it gets wide and it gets narrow. The water flow is going through that channel and you measure the discharge. You'd call it the discharge through the wide section. Mm-hmm. And then through the narrow section, what you'll find is it's going to be the same. Well, if you've got a wide section, what that means, it's going to be shallower and it's going to be moving slower. If in a narrow section, and you can do this, and this can be kind of an exercise, a thought exercise for you. If you're out hiking, you're looking at a creek or a river, start noticing things like this. Notice that if the creek narrows, you'll see that that's where the white water is forming because that's the water is speeding up. See? Yeah. And when it's speeding up, it becomes more competent to pick up sediment and carry it along. Okay. Now it gets to a basin where it widens out. What does the water do? It slows down. Now, as it slows down, remember, the velocity of the water determines the size and volume of the sediment. So if the water starts slowing down, first thing that happens is sediment begins to fall out. Mm-hmm. What falls out first is the big stuff. Mm-hmm. Makes perfect sense. So now you can look at a bar and you can go, okay, and let's say that this is a non-functioning flow. Let's say it's what we call a paleo current. Okay. Meaning it's an ancient current. And
so it's like a dry bed?
Yes. You got it. Exactly. So you're looking at this dry bed and you see a bar and you go, okay, I wonder which way the water was flowing. Well, the big stuff is going to be on the up current and the finer stuff, and it's going to get progressively finer as you go down current. see, because the water's slowing down.
Yeah.
And that's just one that is called, and here's, there will be a quiz on this later, Danica, but the term for that is when you're out tracking these floods in the field and you can't see the water flow. Of course, you're going to look at the gradient. Obviously, if the slope downward, the water's going to be going that way.
Right.
But, it might be you're out in the field and you don't necessarily know the gradient. And sometimes with really big floods, sometimes it can flow uphill and flow. You've got, that can actually happen. Yeah. So the term that the hydrologists use is paleo current, meaning an ancient current, an old current, paleo current indicator. And there's a suite of these different things that you use and you learn to recognize them in the field when you're trying to reconstruct these gigantic ancient flood events in your mind. So what I was doing was taking people out and essentially in the field with real world examples of this stuff. Now, one of the places that we went to is, it's called, it's the Tammany Bar Gravel Quarry. Some people kind of laugh. I said, well, where did you go? Did you go some really cool? But yeah, man, we went to a gravel quarry. They're like, what? Well, it wouldn't be exciting for somebody who didn't understand what we were doing there. Okay, so this is where we were touring. And you can see here, this is the Columbia Basalt Plateau of eastern Washington. Okay. This is where a lot of the action happened. But this place that I'm talking about now, I'm going to zoom in right here, and you can see the Snake River coming up to the north. Okay. It bends right here at Clarkston. There's Lewiston, Idaho, Clarkston, Washington. And it's at the confluence here. You see the Clearwater coming in this way. This is the Snake. Whoops. And we can go down here. This is coming out of Hell's Canyon here. Okay. Well, the area of interest is right here in this area. Yeah. You see where it says Tammany Creek? Okay. Okay, so all this right here is a gigantic boulder bar, gravel bar, and you can see how it's on the inside of a meander, just like we talked about. Yeah. Right. So what's interesting about this place, and I don't have the slides to show you what we saw, but I can give you the sort of a visual explanation, is that you had two gigantic floods, one coming north up the Snake this way. You had another back flood. Oh my God. Down the Columbia. This is the Columbia right here. Okay. And we can see that there was, when I zoom out here, I'm going to show you. So I'm going to switch here to the satellite view. And now you'll notice that there are these large dark areas. Yeah. And there's you can see agriculture around here. There's no agriculture here because the topsoil, which is an interesting material called loess, very fertile, but this is a semi-arid area, 15 inches of rainfall per year. So it's being activated by a huge irrigation system, feeding water from the Grand Coulee Dam. What happened here is you had this tremendous flood coming down. It washed away about 200 feet of topsoil to expose this lava rock called basalt that sits under the bedrock. It then began to carve its way into the basalt. And when that flow, which was probably about 250 million cubic feet per second, and we'll talk about to try to give you a handle on what that means. This gigantic flow came down here and it hit the pre-existing Snake Valley. And when it did, the water diverged to the west, which was downstream Columbia, but it also reversed the flow of the Columbia all the way back up here to Lewiston. So what happened here is that you had these two tremendous floods that met. This one, let me go back to here. This one here, if we go back to its origin, I have to zoom out. And if I go all the way down here to Great Salt Lake, have you ever been Salt Lake City?
Yes, I have, yeah.
Okay, well, Great Salt Lake right here is a puddle. It's a remnant left over from gigantic Lake Bonneville. And you know, I'm sure that the Bonneville salt flats.
I figured that's why you called it Bonneville, because of how much speed at which the water was moving. Maybe it was nicknamed after the Bonneville salt flats being where people set land speed records.
Well, the Bonneville salt flats is named after the Lake Bonneville, and Lake Bonneville is named after one of the explorers.
Okay.
I think who first identified it.
Okay.
Well, modern day Salt Lake is literally just a few feet deep. But Lake Bonneville was nearly 1,000 feet deep. And it rose suddenly near the end of the last ice age, and it spilled over a pass, a saddle, if you want, right through here. And the estimated discharge through here was about 40 million cubic feet per second. It discharged here and flowed all the way down what is now the Snake River Valley, and then came up through Hell's Canyon and discharged up here at Lewiston. Okay, at the same time, the Missoula flood is backflowing. Like I said, it reversed the flow of the river. Now, you have geologists that have looked at the Bonneville flood, as it's called. You have other geologists that have looked at the Missoula flood, but they have not necessarily correlated these two gigantic flow events. Now, I was interested in the timing because there's variability in the estimates of the timing. I'm going to stop share now. We don't want to get Jen mad. Okay, so there's variability in the timing. These two flood events have not been correlated. The question in my mind is because I've followed these routes many times, looking at them, wanting to know what's the correlation. What's the timing of it? Now, in one case, you've got a big lake in Utah, rises up 1,000 feet deep. At the north, where the breakout point was, picture this. You've got soft sedimentary rock. It's about 350 feet thick, and it's sitting on top of a really hard granite layer. Call it a granite sill, just like your door sill.
Mm-hmm.
Sometime around the end of the last ice age, Lake Bonneville rose up, spilled over the dam, the sedimentary rock dam, and quickly eroded it down 350 feet until it got to that granite sill. At that point, it stopped. So up here, when it spilled over, it was nearly 1,000 feet deep. It eroded down, so now it's about 650 feet deep. It has no outlet to the ocean. So what happens is, with the climate change that came in the wake of the end of the ice age, it went from relatively temperate and lush to being desert-like. So what happened was Lake Bonneville, over the next couple of thousand years, just evaporated away and left Great Salt Lake as the remnant, right? Mm. If you look, in fact, I could pull up slides if we want. If you look at the hills on the Wasatch Mountains, immediately to the east of Salt Lake City, you can see two shorelines etched into the side of those mountains.
Oh, wow.
One of them is the high water mark, which took estimated several months for that 350 feet of water to drain out. Then it stabilized at that granite sill, and at that point, there's another shoreline etched into the mountains. You can see it very clearly if you know what you're looking for. So here's the thing. The Bonneville flood is flowing downstream, but you have the Missoula floodwaters are back flooding, so they're essentially flowing upstream. Now, this is logical if you think about it. Water flowing downstream, it's going to be moving fast, generally, depending on the gradient. The water back flooding upstream, it's going to be moving slower and slower. And you can see this during any flood event. If you have a major trunk valley, huge gushes of water coming down there, it back surges into the tributaries. The water rushes up the tributaries, slows down, stops, and then when the main trunk valley drains away, you have a reversal of current, and that water in the tributaries will then drain out. But what it does is it leaves a calling card behind of fine, silty muds. Why fine, silty? Because the water has been moving slow.
Oh, yeah,
and
little stuff.
Yes, it makes all this, I hope, is making sense.
Yeah. Well, as you said, the big stuff is what goes when there's a lot of flow, but as it slowly erodes and goes down, then all that's left is essentially the sand.
That's it. Even sand, silt, and fine grained, really fine grained stuff. So getting back to Tammany Bar, and what's significant about that is because at that point you have the interaction of these two flood events. And in some of these gravel outcrops that you can see inside the quarry, they're very distinct. The material that was coming up the snake, that's flowing down, so it's faster moving water. And you can see right there in these sections where they've been quarrying the material away that it's very much coarser. And then on top, and it's gray colored, then on top is a much finer grained, silty stuff where you can see the current ripples in there. And this is where that Missoula floodwater reached its distal point and reversed currents. So what I was interested in is this: how much time separated these two events? Were they separated by centuries? Were they sent by millennia? Or did they happen at the same time? So what I did was we went in, we got permission, special permission. We got a guided tour of this massive quarry that's in the Tammany Bar. So we were able to go in there and see, and I was able to interview the manager of the quarry there. And what I wanted to know is, you've got these two layers. In fact, I could probably pull this up and even show you pictures of what I'm talking about. It's pretty amazing when you see it. And I think when you do see it, you'll understand exactly what I'm talking about. So I'm going to, while we're talking here, I'm going to quickly open another slide here. And
do you think that these, all the things that you're talking about with how geology works and the water, the current and all of the evidence that you find as to the speed and the direction and everything, is this just something people don't use enough? Because when I even think about, the Sphinx in Egypt and how, they're trying to date that, but there's people, there's yourself or Graham Hancock or so many have been like, look, there's water erosion here. And then I think to the larger scale of the planet, which we touched on the last time, which was global warming. It's like the planet over hundreds of thousands of years, millions of years, goes up and goes down and big swings. And while it looks like everything's getting warmer, are we just in that phase right now? And, there are so many places they find old evidence of maps that made Antarctica look like a jungle. And so, you think about it and just people think it's always supposed to be static like it is, but it had entirely different landscape depending on what wave of heating and cooling and what water had flowed over these places to either make them deserts or make them lush or whatever the thing is, because, the planet is a living, breathing thing.
Yeah, and you're exactly right. And here's the thing: people don't understand how dynamic the planet is in terms of climate and environment and so forth. It is extremely dynamic. I'm going to pull up a slide here in a minute to show you. It'll just drive that point home. I wanted to show you this because I think you're going to appreciate this. We talked about the mountains. Hopefully you're seeing this.
Yeah.
Good.
It's beautiful.
Okay, I took this from the air, and if you look over here, we're looking east. This is the Wasatch Mountains, and this is the northern part of Salt Lake City here. You can see the water mark right there on the mountainside. Yeah. That high water mark is almost 1,000 feet above the floor.
Oh, wow.
If I go here, you're going to be able to see the two shorelines I was talking about. The upper shoreline is there, and then there's the lower shoreline.
Wow.
And this shows us how much that water level dropped once it breached the sedimentary rock dam at the north. So here's just some of the specifics on Lake Bonneville. 20,000 square miles, maximum depth 1,033 feet. I don't have the volume there, but then here's the elevations of those two shorelines. You can see here that here's the elevation of the pass that it breached at the north. So you can see there's only a 5-foot difference then between once the water level dropped, it cut that new shoreline. And here is the Bonneville flood, the peak discharge, 35 to 41 million cubic feet per second. Now, the greatest flood disaster in recent American history was the Great Mississippi Flood of 1993. And peak discharge there was over double the normal flow of the Mississippi, and it was just above a million cubic feet per second.
Oh, wow.
So that gives you some sense of scale. 40 million cubic feet per second, that would be almost like 40 Mississippi rivers as its largest ever measured peak discharge.
Oh, my goodness.
Total volume of water drained, 1,140 cubic miles. Assumed duration, several weeks to months. So this is what's being transported within those floodwaters.
So much water is moving so fast.
Yeah. And okay, so once boulders of this size are dropped here, they're they haven't moved since the day they were dumped there. Because nothing has no flow of the Snake River. Right, exactly. Okay, this is a great photo here because, as it says down below, scale invariance. So the Snake River, which is down here, which is a pretty good-sized river, is flowing within the giant Bonneville flood channel.
Oh, yeah, it's just a fraction.
This is a textbook example of an underfit stream. And so here you can see modern Snake River, 56,900 cubic feet per second. But the estimated discharge of Bonneville is up to 40 million cubic feet per second.
Wow.
So here's the thing, Danica. You can look at rivers all over North America. And what's unique about this is because of the environment, it's not covered in forests, trees. If you had a different environment, temperate, you would have forest growing here. You wouldn't see this. You wouldn't be able to see it so clearly.
Right.
Virtually every river in North America displays this same kind of evidence. Even rivers that, in the southern Appalachians, rivers in the Southwest, out near where you are. I can show you the same thing, that you have these giant channels. And of course, the modern rivers are going to flow into giant channels. And once, like, for example, a big flood of the modern Snake might transgress onto this floodplain that you see here, but nothing has remotely come of magnitude that would allow it to overtop this big channel. So what that says is that the modern rivers, they've been captured into these oversized channels, and once they're captured in, they don't get out again. Because again, a point to keep in mind here is that no event along the Snake River, even the largest modern measured floods, are even remotely close to this flow of 14,000 years ago, which brings us back to the question. What is the timing? So think of this, Danica. You've got two big lakes. You've got a lake in western Montana called Lake Missoula. You've got a big lake in Montana held in by a glacier dam. You've got a huge lake down in Utah held in by a sedimentary rock dam. Both of them exploded out of their basins and created catastrophic floods. Modern geology doesn't necessarily look at any correlation or unifying explanation for those floods. That's what I'm looking for. The relationship of these two floods. This is some of this, again, this is a sediment. It says here, Randall and giant flood rolled boulders in the Snake River Canyon. This is a boulder bar. It's 3 miles long. It's hundreds of feet thick. And this is what it's composed of. So this is Tammany Bar right here. And here's the gravel core. And I took this from the air, or where did I take this? I took this maybe 20 years ago, actually. So there's been a lot of quarrying that's gone on since then. Here's the bar right here. So it's right here where you can picture these two gigantic floods met. This is where they met, right here. Here's a cross-section of Tammany Bar. They've been quarrying you can see the very distinct line here, right?
So that's below, right? That you said.
Below. You see this little guy standing right
yeah, there is a human there.
Actually, that guy with Mark, he was 6'6" tall. So, but so you can see there's two different types of sediment here.
Oh,
this is down current from the right, up current from the left. Let's zoom in a little. Now you can very distinctly see the difference, can't you?
Wow.
This is Bonneville flood stuff.
Yeah.
This is ultimately coming from Utah, southern Idaho, Snake River Canyon. All of this is the slowing back floods, what we call slack water sediments. So this is the fine-grained mud, basically, that's being washed upstream by the Missoula floods. Now, the reason we went here and why I was very interested in this place is I want to know how much time separated the Bonneville flood from the Missoula flood or floods.
Did you figure it out?
Well, the evidence that I found showed me that very little, if any, time separated. And this is what I was seeking to answer. Are these separated by centuries or millennia, or are they happening at the same time? The evidence that I found there when we toured this gravel quarry was that they were happening at the same time. Now, if that's the case, it raises a question. Is that merely a coincidence, or are they both responses to some greater forcing mechanism that triggered both of them? That was the question in my mind.
Like a cataclysm or like a warming.
Something that was bigger than
like a nuclear war in ancient times with different phase of humanity.
Maybe. I tend to think my first guess is impacts of things from space causing enormous climate change. The second would be the sun. And actually, I have reason to believe that they might work together. What we're seeing right here is this transition between the darker colored Bonneville and the lighter colored silty stuff. How much time elapsed between these two right here? Well,
or was that some sort of a settling? Was that just a natural settling?
Well, okay, good question. Okay, one of the things that we'll do, I'm going to go here. So now you can see some of the fine-grained silts up here.
Yep.
And if you look, there's an architecture to this.
Yeah, there's like a flow almost, like you can
see. That's exactly it. That's exactly it, Danica. It's a flow from right to left, and you can see these strata are tilted down, aren't they? They tilt down in the direction of current flow. So if you're a hydrologist, you look at this and you can say, look, there were surges of gravel sediment loaded currents coming from right to left. Up here, it's from left to right. Now, this is high energy. This is low energy. High energy erodes, low energy preserves, because what it does, it's moving in, and whatever is there, it's not going to get washed away. It's going to get buried in the mud.
Right.
Does that make sense?
Yeah, of course.
So if we go back to here, here's the question. If this was here and any amount of time elapsed, say between the stuff below and the stuff above, you're going to have all kinds of vegetation growing there. You may even have trees. You're going to have shrubs. You're going to have grasses. You're going to have pollen. You're going to have all of this stuff that indicates there was some hiatus. I mean, go out and look at a bulldozed site where there's nothing, and then come back 10 years later, there'll be trees growing there.
Yeah, exactly. It's nature always finds a way.
Yes. So the question in my mind is this. Well, if there was any time elapsing between the deposition of these two layers here, there should be evidence in the form of vegetation. So I was able to talk to the quarry manager, and I said, now, when you quarry this, do you find evidence of any kind of vegetation at all? Anything that would indicate that it had been there for decades or centuries between the Bonneville below and then the Missoula above? And his answer was no, we never find any of that. He gave us access to a deep pit that they had quarried. And let me go back here, because what I was wondering was, okay, did the Bonneville come in first? And then immediately after it was overtopped by this stuff? Or was this stuff already going on? So he gave us access to a deep pit that was would have been somewhat sheltered. And it was under the Bonneville stuff.
Oh.
And what do you think we found there? Was
vegetation.
This stuff right here.
Interesting. Why?
Now, yes. Okay, so what this is telling me, Danica, is that this is evidence suggesting that these two events were happening simultaneously.
Yeah.
Okay, no theory about the origin of these recognizes that there's any correlation between the two. They're two separate events in the textbooks. I'm going to argue that no, they're not separate events. They're both regional expressions of something greater. Here's where you can see actually the reversal of the current. The water, the slower the water is moving, the more level the strata that it creates. And you can see how they're kind of level down here.
Yep.
And then look what's happening here. Between this level here and this is
something was raging.
The current reversed right in here. It's flowing left to right here and right to left here. Here it's still flowing upstream and it's moving really slow. So the sediment has no structure. It's just layers, horizontal layers.
And that takes time, right? So this
may have been deposited literally over a couple of days.
Oh, wow.
Even a couple of hours.
Okay.
But once it gets to the distal point of its flow, it then reverses. Now, of course, once it's reversing, it's now flowing back downstream, down gradient. And that explains the difference, because here you can actually see the ripples, which is showing that it's picking up velocity. So right near here, the water's coming in this way, slowing down, stopping, and then reversing current and flowing back out.
By saying that timeline, you can go to those locations and say, what happened here? What happened here? Do you know what those two events were that would have led to something like that?
Clearly we have now the Bonneville flood had to have been, Lake Bonneville didn't have it was not adjacent to the giant glaciers like Lake Missoula in western Montana was right there. I mean, it was lapping up against the glaciers. And then you had glaciers to 1,000 miles to the north up to a mile thick, right? Lake Bonneville was in a bedrock basin. Bonneville had to have been fed by rainfall. When we know that there was more rainfall during the Ice Age, during that, what is now arid desert was receiving a lot of rainfall during the Ice Age. And the reason is because when you have 1.5 miles thick of ice forming over the continent, it pushes the jet stream to the south, and the jet stream is carrying all that moisture. So the jet stream got pushed down over what is now the desert areas of southwestern United States.
That's right. I learned that from a pilot. When the cooler weather comes in, it pushes the jet stream down, because we were talking about flying east to west coast, and that it's not so bad going east to west coast on the sort of southern part of the country, middle part of the country, because the jet stream's so far north. But as soon as the winter comes in, it pushes that jet stream down. And now flying west is much more time consuming because of the jet stream.
Because of the jet stream. And now think, and what he said is absolutely true, but now think in terms of an ice age, when you have 1.5 miles of ice, how much more extreme that phenomena would be.
Right.
You see? And so what that did was delivered a lot of rainfall, but so undoubtedly Lake Bonneville probably existed for millennia. But right at the end of its lifespan is when it suddenly deepened by a considerable amount and then overtopped that soft sedimentary rock to the north. So what it implies is that there was a whole lot of rainfall at the very final stages of the lifespan of Lake Bonneville. If there's a whole lot of rainfall, then you need to have an explanation of why would you have this, and it would have been extreme, because the basin is huge. And to cause it to raise hundreds of feet very rapidly means that you had enormous rainfall events. So the question then, we've got failure of an ice dam in western Montana, and we've got failure of a rock dam in Utah. In my mind, I'm looking for a larger cause that can explain both of those events happening simultaneously. Now, if we could somehow cause a very rapid melting of the ice sheet to the north, that's going to have atmospheric consequences. That rapid melting could be associated with the injection of enormous amounts of water vapor into the atmosphere. We now know that the that the melting of these great glaciers was extremely fast. In fact, it happened in pulses. It wasn't a smooth, uniform thing. It happened in, it looks like now, 3 tremendous pulses of melting.
Those pulses would be caused by cataclysms possibly, or would this, because you started talking about the sun, and I don't know if that taps into sort of this architecture of the solar system that I've heard you mention.
Yes.
I don't know if that plays into it, but is that what you're thinking, causing these pulse of heat that would?
Yes. So now,
melt?
if you have 3, let's take 3 pulses of melting, and here's the closest dating of those: 14,600 years ago, 12,900 years ago, and 11,600. Okay. The 12,900, that's called the lower Younger Dryas boundary.
Right. Such a controversial time.
At that particular boundary, there's all kinds of impact proxy evidence that has been, in my mind, confirmed to be real.
Right.
In other words, nanodiamonds, trillions of nanodiamonds, an iridium spike, a platinum spike, also, what else? Oh, microspherules, which only form in extreme heat and pressure. And these are now being found in large swaths of the planetary environment.
And that impact site was where? Where's the evidence most commonly found?
Well, see, the primary objection to the impact is that the critics of that say, well, where's your smoking gun? Okay, you've got nanodiamonds, you've got exotic cosmic metals, you've got microspherules, you've got magnetic grains, but where's the impact crater? And until you can show an impact crater, we're not buying your theory. That we don't care how much proxy evidence you find. Mm-hmm. We're not going to buy into this. You got to show us the crater. Well, I think that we can identify the craters at this point. I think that could be as many as 7 to 10 impacts.
Okay, that would make sense, that something could come in and it would break apart.
What we know now about the structure, for example, of comet nuclei, even asteroids, is that they can fragment. Right. And you can have a multiple impact event. Right. And a lot of the scenarios about impacts, I think, are oversimplified in that they're looking for just one big object coming in, slamming into the earth, digging a big hole in the ground that we can now identify and say, okay, we know how many impacts there are because we're counting craters. But I think, did we talk about the Tunguska event of 1908 last time?
I think we did, yeah.
Yeah, that was probably a piece of a comet nucleus, and it didn't hit the ground. That's important. It didn't hit the ground. It exploded maybe 5 miles up in the atmosphere, which is actually more devastating than it hit the ground. It's for that reason that, when they bombed Hiroshima and Nagasaki, those bombs were detonated several thousand feet up, because now you've got the greatest radius of destruction. Mm-hmm. And that's what we saw with Tunguska. Now, Tunguska occurred on June 30th, 1908. Well, June 30th is the peak of the summertime torrid meteor shower. And
we had talked about that there every year there's a huge meteor shower that sort of passes us, right?
We pass through the torrid
1 or 2 times a year.
Twice each year.
That's right.
Because, yeah, I almost want to pull up another graphic now, because I've done a really nice graphic to show.
Great. Yeah, if you have it, pull it up. I mean, I was really very frightened after the last time when you told me about that, because it just shows how vulnerable we are, that there is basically 2 meteor showers a year that we pass through, and it would just take nothing to just miss by a couple 100 miles or 1,000 miles or 1,000,000 miles one direction or the other. I mean,
well, in September, there was an 800-foot asteroid, came just within a whisker of the Earth. It was well inside the orbit of the moon, and an 800 now, it wouldn't have caused a global mass extinction event. But what would have happened if that object had been on a slightly different trajectory and it had impacted? Okay, first thing that happened, it could
ricochet off of another one and just change its trajectory a little bit.
Well, yes. Or what we now also know happens is that when they make close passages by a larger gravitational source, it can nudge it so that the next time around, that's exactly what we saw in 1994 with Shoemaker Levy 9. Anyways, so slightly different. What would have happened? Well, if it had slammed into the ocean, all coastlines of that ocean would have had tsunamis that made landfall, would have been a couple of 100 feet high, the wave. If it had landed on, and it would have also injected huge amounts of water vapor into the atmosphere, which is going to rain out, and you're going to have some hellacious rainstorms somewhere, depending on air currents and all of that, atmospheric movement, all of that. If it had hit the land, let's say eastern United States or western United States, an area about the size of Pennsylvania would have been erased from existence. It would have created a fireball about 3 miles in diameter, which would, say, if it's a populated area, would have instantly vaporized over 1 million people. Then there would have been millions of secondary deaths because you're going to have the debris goes up in the atmosphere, falls back down, and starts secondary fires. Second, all those fires and all that particulate matter into the atmosphere is going to increase the opacity of the atmosphere, which is going to reflect more sunlight, which is going to cause a temporary 2 to 5 year global cooling. Within that period, you're going to have sort of a replay of the year 1816, which has been called the year without a summer, which has also been called by historians the last great subsistence crisis of Western civilization. And what you had there was the accumulated effects of 4 closely spaced volcanic eruptions that put this veil in the atmosphere.
Oh, yeah, and it kept us cool, like we didn't get sunlight.
Right. So you had crop failures, which led to starvation. Now,
people worry about global warming, but a lot less lives when it's cold. Like we don't exist if it's cold. So embrace the warmth.
Embrace the warmth is exactly my philosophy. I think I think that really it's misguided and a gigantic distraction.
Right.
Because it's just bizarre, Danica, that people have called me, oh, Randall Carlson, he's a climate change denier. And I go, stop. I'm talking about climate change that dwarfs. I'm constantly and have been for decades talking about climate change that dwarfs anything we've seen this century. How am I denying climate change? Who's the one who's really denying climate change here? I don't think it's me. And since we're talking about that, let's see if I've got, this is going to be, I'm going to do another share screen here. And this is what real climate change looks like in terms of this graph. Now, the graph that I'm going to show you is based upon oxygen isotopes. So back in the late 80s, early 90s, we accelerated our coring projects in Greenland and Antarctica.
Mm-hmm.
Now, Greenland is it's over a mile thick, the ice.
Mm-hmm. Mm-hmm.
The U.S. and Europe did a joint venture, two drill cores drilled all the way to bedrock, right? Mm. Now, that comes out, and what you have is layers in there.
Sure.
You can count those layers because each year the snow falls. Yeah. The next year, another layer, it gets compressed, and it forms this layers that can be literally counted. Now, as you get down, they're harder to discern, but you can use electrical techniques to discern the difference because, for example, if it's real windy, let's say, and the wind is coming from the west, and let's say you've had large forest fires that have burned away the forests. Now you have a lot, when the wind blows over an area that's been destroyed by forest fires, it picks up a whole lot more stuff in the atmosphere, right? So we can look at these layers in the Greenland ice core and we can see, oh, there's a layer of volcanic ash here. So there was a volcano exploding somewhere. Oh, look, there's a layer of soot. So there was a forest fire going. Look, the layer of soot is followed by a layer of dust because after the fires burned everything away, the wind now picked up. So it's like detective work.
Got it.
So oxygen isotopes are a function. I won't get into the technical background too much, but oxygen isotopes are a function of temperature, right? And what I'm going to show you now is I'll do a screen share here again. And what you see here is oxygen isotopes in Greenland. Now, let me explain what we're looking at here. Changing ratios of oxygen 16 to oxygen 18 is a proxy for climate change.
Okay.
So oxygen 18 is the heavier oxygen 16 lighter weight. And so when, and it's, let's say it's in the ocean, it's being evaporated out. And the warmer it is, the more energetic is the atmosphere. It can now transport more of the heavier oxygen.
So is 18 warmer than 16? Like essentially is what it's trying to say?
Basically, yes.
Okay.
Yes. So when it gets cooler, the energy available to evaporate the ocean water gets less.
Okay.
And so now the heavier oxygen is preferentially left behind.
Okay.
Well, this leaves its imprint in the ice. Okay, because when it rains out, whatever those oxygen 16-18 ratio is in the ocean water rains out, and that's preserved in the ice cores. Okay, so that's just a partial explanation. So now, if we look at this, to the left means cooling, to the right is warming.
Mm-hmm.
We can go down the right vertical axis to 10. This is thousands of years.
10,000 years.
10,000 years ago.
Okay.
Now, when you look at this wiggle here, one of the things to notice is that it's not a smooth line. It's oscillating back and forth.
Sure.
Well, those oscillations are 1 to 4 degrees in amplitude.
Oh, wow.
And what's yeah. So, I mean, this is the climate's been oscillating back and forth for thousands of years. Okay. We can see some interesting stuff here. Right here, you see that little spike down there?
Yeah.
That is a 3 to 4 degree sudden cooling in the Earth's climate that occurred around 8,200 years ago.
Not good.
If a cooling like this occurred today, we would probably have global agricultural failures.
Exactly.
For half a decade at least.
Randall and I'll say it again. Embrace the warm.
Embrace the warm. Yeah. Look at here.
There's
a warming spike. We don't know what caused it, but something could have been the sun. We don't really know. Look, it happened around, just about maybe 2,400 years ago. There was this warm spike. MWP means medieval warm period, which was actually a time of prosperity in European history. But now, if you want to see what real climate change looks like, I'll say down the left, this is 1,500 meters. So this means 1,500 meters of depth within the ice sheet.
It.
So 1,500 meters is about almost 5,000 feet. So we're down almost a mile of ice.
Okay, is that and is that correlating with 10,000 years ago on the other side or it's just a separate scale? Because that's okay.
So when
erosion and
when they cored down to 1,500 meters, the ice that they were looking at was 10,000
years old. Okay.
Okay, so now look at this. There's real climate.
How old it was. Yeah, exactly. Thank you, Randall. Exactly.
Yeah.
That was not a good time.
No. Now, here's the thing. If you get somebody saying to you, there's a consensus on climate change, the science is settled. All you have to do is ask them, okay, well, what's going on here? Explain this to me. And you know what? They won't be able to. Because the science isn't settled. There's only a manufactured consensus. But when you really begin to look at the data and the evidence, we've got things like this that just we have no explanation. What happened look at this down here.
Right. All of a sudden, you've got this enormous spike of warming, several spikes. This is a period, interestingly, called the Eemian. And you can go back to the Eemian, which is now dated between 116,000 years ago and 129,000. So a span of about 13,000 years.
which is to me interesting because it's been 13,000 years almost since the Younger Dryas event. What caused this? Nobody really, there's ideas, people are discussing it, but nobody's settled on what caused. I mean, look at how cold it was and look at the magnitude of that spike right there.
Right. I mean, these things have to be more solar based because if it's something hitting our planet, it essentially is going to send things up into the sky. And I would think, like you said, like create a layer of cooling that would protect us from the sun. It seems like it'd have to be the sun that does it.
Well,
something like a solar flare or something like that.
Something like that. Now, one possibility is that if you have an impact into the ocean, what that does is it puts up a vapor canopy.
Right. Okay.
And water vapor is the most effective greenhouse gas.
Okay.
So if you have a major, now, maybe it could be solar potentially, or it could be like an impact into oceans.
Yeah.
Both of them could inject large amounts of water vapor into the atmosphere, which it now could induce a runaway greenhouse effect. Because again, water is the single most effective greenhouse gas.
Yeah.
This area right here, this is coming out of the ice age. So this is that 14,000 year spike, 14,600, and there's a global meltwater pulse right there. Then the Younger Dryas was this extreme return to glacial cold after this warming. Then there was a second major spike here that brought essentially the planet out of the ice age.
Yeah. How did we get consistent? Like, how did we we're living in like the golden age of temperature by the looks of it.
The golden age of temperature would have been this, take away this spike here. This was what's called the climatic optimum.
For almost 5,000 years, it looks like, or 4,000 years.
Right. Now, I kind of think of this as being the golden age because number of reasons. Well, for one thing, after the ice age was over, you had the glaciers melt back and you had huge millions of square miles of land surface that had been buried under the ice that were now released from the ice. It took about a millennia or two for nature to reclaim those areas. But you know that one of the great mass extinction events in Earth history occurred at the end of the last ice age. I think we talked about that somewhat. You know, that how in terms of the fauna that existed on Earth during the ice age was completely different. Well, I mean, a lot of the species now existed then, but you have to almost visualize that the mega mammals, megafauna, which are defined as 44 kilograms body weight or more. Yeah. In round numbers, that's just about almost 100 pounds in body weight. So I clearly qualify as a mega mammal. I don't know where you fit on the scale. But just you're just barely, okay, so you have the distinction of being megafauna or mega mammal. So, but if we go back to the late Pleistocene, which was the last few millennia of the Ice Age, you got roughly twice as many species of large mammal on Earth as we do today. And if you start thinking about those beasts, those Ice Age beasts, you usually wouldn't think that, if you went back 15,000 years ago and went out your front door, you might see Columbian mammoths walking around.
No, I see a coyote. I'm in Arizona. I see a coyote.
You see coyotes, but you don't see any 6-ton proboscideans.
I see a 35-pound coyote.
You don't worry about packs of dire wolves.
No.
With twice the jaw power of modern wolves. No. You don't worry about the giant short-faced bear.
Something I'm very curious about. So if that's the kind of animal life that we're talking about, how can we not have a difference in potentially what human life looked like? And I wonder so much when I think back into ancient times, and you think back to everything from the pyramids to the cathedrals to the beautiful architecture, just, the way the megalithic stones and structures that were built. And you just think to yourself, we don't know how they did it. And I wonder, were humans part of that too? Have there been just waves of some iteration of a human that have been on the planet that nearly get extinct and wiped out, and along with it goes technology, and essentially we start over again?
See, I think you're hitting the nail on the head, Danica, because when I was talking to Jen yesterday, I said, "Do you know really how old modern humans are?" We don't really know, but we keep getting older and older. When I started giving these lectures, several decades ago, the oldest modern human remains were 80 to 100,000 years old, which I thought, that's pretty old. And we've been around modern humans a long time.
Yeah.
Well, it's double that now.
Exactly.
It's double that. So if we accept 200,000 years as being the oldest modern human, 25 years as the length of a generation, there's been thousands, maybe up to 7,000 generations since then. Now, if you look at how quickly we rose from like subsistence farming, hunter-gathering, feudalism into the modern scientific age, a few centuries, really.
I mean, we do it pretty quickly.
Very quickly.
We figure things out quickly.
Now, here's my problem with the prevailing narratives of ancient history is that, okay, in fact, there's even evidence now that our brain size has actually diminished by 10 to 15%.
That's right. I've heard that too.
So, which to me even contradicts further that, wait a minute, are you going to tell me that for a couple of 100,000 years, there was no accumulated learning? There was no wisdom passed on from one generation to the next? These people had brains bigger than ours. They were able to survive the rigors of the Ice Age, but they weren't as smart as we are. They didn't invent any technology. They didn't have any accumulated learning, no science. I find that untenable.
Right. Bigger brains, yet did nothing with them.
Did nothing with them for generation after generation after generation.
You don't stay a caveman with a bigger brain.
Yeah. Well, that's kind of the standard image, the caveman.
Exactly.
For thousands of years, the caveman, right? Well, what a lot of the archaeologists, and most of them, in fact, from my impression, is that they don't understand how extreme have been these climate changes and what that has done to the surface of the earth. And I can tell you this, and I can say this pretty much without equivocation. If something equivalent to the Younger Dryas were to happen today, 10,000 years from now, archaeologists would be hard-pressed to find any evidence that our civilization was here at all.
I mean,
that being the fact.
Point. Exactly.
How can
I'm thinking about like these cataclysms or whatever could happen. I'm like thinking, what's underneath the ocean? Like, if it clears like, how would you ever find us again? Paper dissolves, like the walls, like it goes back into the stone that it was. It tumbles into a rock. The bricks that filled my house are gonna turn into small pebbles. That go from squares to round, and you'll never know.
Right. I mean, think about the Golden Gate Bridge. I mean, there's constantly maintenance and upkeep being done on the great industrial infrastructure.
Yeah.
If that were to stop within a few centuries, take our biggest skyscrapers. Within a few centuries, nature is reclaiming those. Within a millennia or two, particularly once the grounding systems have decayed away, they're going to be lightning strikes. Basically, within 10,000 years, the infrastructure of our civilization is gone. What would you find 10,000 years from now to show that we had been here? Well, two things that I've seen mentioned are the Great Pyramids,
of course,
and Mount Rushmore.
It has to be made of natural stone. I would think like something natural, something huge, something above ground so far that perhaps water can't affect it.
Megalithic.
Yes,
that's what would survive is big stones. So I'm of the mind that we definitely need to rethink the potential of prehistory. And I think when we do, and when you start looking at open mind, there's so much stuff that just doesn't make sense in my mind. I've earned my living most of my adult life as a builder. So sometimes I have had to, been confronted with having to move heavy loads, half a ton to a ton. And I know what's involved with that, and Yeah, there have been times when we've raised a half-ton beam or a ton steel I-beam up a couple of stories manually by using pulleys and blocks and tackle. And one of the ways we've done it is, you've got your big I-beam sitting there. It might be 14, 16 inches tall. You got to lever up one side, and you essentially put a shim under it. Then you lever up the other side, and you basically just walk it up, right? Of course, the preferred method is you use a crane and just pick it up and set it down. We build architects, engineers, we build with stone all the time. But the stones we build with are small. They're 50.
So you're not buying that in ancient Egypt the slaves used, palm trees and ropes, and that'd be so hard to do on flat ground, let alone where the quarry that it came from, and the boats that they say that it came down.
Yes.
Let alone now pulling it uphill. It's hard enough to walk uphill.
Yeah, but much less. Yes, there's all kinds of problems with that. But I guess then what I'm getting at is that when you look at modern stone building, our stones are you might mostly now it's stone veneer on buildings. We don't actually even build structurally with stone anymore. But in the 19th and early 20th century, there are many beautiful examples of building structural stone, right? You had stonemasons building up, and typically those stones are going to weigh 20 to 100 pounds maximum. Nobody's building with 50-ton stones. Nobody's building with 10 tons of.
I'm building a guest house in the backyard, and two of the walls that just got built, they're actually complete concrete walls, and they build essentially like a casting, and then they pour the concrete into it, and now they've taken it off, and so it's it's a much more intricate process, and then it's being built, like the whole house is built out of stone, which, as the GM told me the other day, for the project, he's like, this is not the most common way. Like usually it's, you have a very unique built house, so it's but this is so uncommon. It's normally just like drywall and insulation and.
So are these the exterior walls of the house? Or
essentially they're going to kind of be interior, exterior. Yeah.
That's good. That's a very stable, durable way to build for sure. You're going top notch there.
Yeah. When we get done, I'll send you pictures so that you can see this.
I'd love to see it. And if I lived out there, I would have loved to have been the general contractor on that.
Oh my God, that would have, I would have just bothered you all day. I'd be like, so if we look over here at this stone, what can you tell me?
No, well, I'm semi-retired now, so I'm not doing the scope of projects that I was doing up to, 10 years ago. We we were forced to scale way back during COVID, and then I decided, well, it's certainly freed up a lot of my time, so I'm going to shift gears. So chances are I wouldn't have even had time to do a podcast with you if we were going like we were 10 to 20 years ago.
Lucky me.
Here's my point, is that we don't build with 10-ton, 50-ton stones anymore because it's totally uneconomic to do it. But what was true for us with the industrial scale machinery we have, it's still not economical for us to do that.
Right.
Minus industrial scale machinery, it would be 1,000 times more uneconomical to build with 20-ton stones. If we're a hunter-gatherer foraging society, it makes no sense. Now, you could argue that given the many cultures that we know existed historically, that there's one really eccentric culture, for whatever reason, wants to build with monumental stone in that scale. We don't know why. Maybe it was orders from on high or whatever it was. They decide that they're going to go to this tremendous effort to quarry, transport, and erect 10-ton stones, 20, 50-ton stones, right? We could say, yeah, these people are really weird, whatever it was that they were obsessive. But we see megalithic stonework all over the world.
Yeah, that's right.
It doesn't make sense. It doesn't add up. As a builder, I look at that and go, it doesn't make sense. Why would they do this? There had to have been a motive, and they must have had a means that we don't know about.
That's right.
To transport stone.
There was clearly a consensus of technology back in those days that covered the globe. And I do wonder whether or not it's just iterations of humans and the way that technology expanded. Perhaps we have more of our expansion in this wave of human has been through electromagnetic frequency, through satellites in space, and maybe we've mastered that in some way that will be unfathomable when people, if and when we're gone, and they can look back and find some evidence of that. Or it's just, I wonder about extraterrestrial intervention, about communication, about some sort of visitation that's given us information and then left, and essentially that technology just dwindles, and the experts, it's like you're a builder, there's so many fewer craftsmen and human beings that can build things with their hands anymore, and build it like they used to. And when they lose that technology and they lose the expertise over time because they don't pass it on to the next generation, it's going to just get worse.
When you consider the natural loss through catastrophic events of knowledge and the deliberate suppression through, when you talk about the Alexandrian library, which it is.
Let's break into that. Well,
there's 400,000 volumes of ancient writings that were lost. Same scale with the library at Carthage.
Maybe the administration this time can get something done. They seem like they're on a war path to the truth. So I'll put it.
You know what? I hope so, and I'm keeping my fingers crossed. If we want to get into politics, I have, my own carefully crafted out plan for where we should go as a civilization, as a nation in the next decade or two.
I think they're listening.
I hope so. I like a lot of what Trump is proposing. I have issues with some other stuff. Of course, by comparison, even though I'm not 100%, and I would argue my point, and I'll get to one of the things I think that really we need to be promoting. Obviously, he was way better than the alternative. I think we can say that. And I am greatly relieved that it came out the way it did. And of course, what we see is that side of the spectrum has gone completely insane, hysterical. Some of the stuff I'm seeing people posting, it's like, they how did it get to this? And then, of course, it brings us back to the whole question of education, indoctrination. We've got a generation now that's been brought up, I think, completely segregated from reality.
Oh, yeah. Well, I think they're dismantling or dissolving the Department of Education, even and putting it back in the states. So there's no
100%.
No federal governing system for that. It's now back to the states, which is a common theme.
Yes, I'm 100% in support of that. I'd also like to see more privatization, and I'm also a firm believer in and advocate for the homeschooling movement, because I've seen what, and some of the.
They're bringing back funding for that too.
That's great, as long as there's no strings attached with the funding, because leave it to local, leave it to, like here where I live, I organize classes for kids being homeschooled for 15 years. Yeah, I had about 120 kids come through these classes. Wow. Basically, it was mathematics, but I taught it through geometry, sacred geometry. So I combined art and math. And the first thing I would do is I would get a new class of kids in, and I would have them drawing using one of these right here, which we custom make these compasses in my shop, right? So they would get a compass like this, and then a simple straight edge, and we would start going through Euclid, and we would go through these, but I would add the dimension of not just Euclidean textbook geometry, but what makes sacred geometry different and much, much more interesting is now you bring in examples from art and architecture and nature, and you show how geometry is at the core of all of these things. The beautiful Gothic cathedrals, the pyramids, the temples.
Golden ratio and how that plays.
Yes, and yes, all of that. So that's what I would teach these kids. Mm-hmm. And like I said, I had 100, 120 of them. But what I learned from doing that is the extraordinary difference between kids that had been not dumped into this big government indoctrination.
Yeah.
Because, kids naturally are eager to learn. They want to learn. They want to participate. They want to learn. Impressionable. And then what happens when you put them in a classroom that's, basically about social control, about, it's no longer, well, you probably well know this. It's no longer about learning to read, learning mathematics, learning critical thinking, learning geography, learning authentic history. It's all now been manufactured to create a specific worldview, a specific narrative.
Well, I think the good thing about me is I didn't go to college. I have a GED even. Like I haven't been to school since I was 16 years old. And so I think that's actually been a blessing.
Yes.
Because it's not conformed me, made my mind rigid in certain ways. I was sort of given no belief system or way of doing things or who to believe and who to trust.
Right.
I'm like a clean palate,
I'm a college dropout.
All right. Cheers.
I had high academic standards when I was in there, but then I had a business to run and I've got a special needs son and he was born and, so I decided to take classes sporadically, which I've continued to do, while building up my business and taking care of my son. So I dropped out, but I was doing exceptionally well. I got the Outstanding Geology Student of the Year award for my college out of, 800 or 1,000 other students.
Oh, wow.
And of course that was, decades ago, and I've learned quite a bit since then. But yeah, so I'm a college dropout. But what I did was when I was in college, I realized, well, if I'm going to go for a degree, let's say if I go for a degree in geology, well, what are my employment prospects, either industry or the government? And that's not really why I was studying geology. I was studying geology because I wanted to know Earth history. I'd already had 10 years of studying and realizing that catastrophism was real. I wanted to know more about ancient traditions. I wanted to know more about the history of the Earth. So I felt like I needed a good, solid grounding in geological ideas. So I took a couple of years of courses in geology, and it did certainly increase my understanding. I learned a lot of the nomenclature and was able to discuss things that, in a academically consistent way that I had not been able to before. But my studies didn't abate one bit after I dropped out. In fact, if anything, they accelerated because that's when I started going out in the field. And what I did was through my homeschool tutoring and courses that I was doing, that was supplementary income. And I used that to fund dozens of recon trips out into the field, which then 5 or 6 years ago morphed into actually doing guided tours. So it went from like 4 buddies going out, in a rented vehicle or whatever, exploring these places in a rented 4-wheel drive, to now taking this trip that we did with staff. We had 46 people.
Yeah. Oh,
so
wow.
That takes it to the next level. But interestingly, I would say at least a third of those people were repeat, because kind of what's happening out of this is people, it's a growing, there's this, I would say it's like, I would call it a community of people who have woken up and go, there's questions, legitimate questions we need to ask. There's an alternative narrative to everything that's going on, to our history, to all of this, and people who are not willing to just be spoon-fed reality, and what I discovered now in the last particularly 3 to 5 years is that this movement seems to be accelerating. And not everybody agrees on everything, of course, but people who are realizing that, there's more to all of this story of the human presence on Earth than we're being told. And we need to learn and get to the bottom of this, because if we don't, it's going to compromise our ability to move successfully and sustainably into the future.
Well, I mean, that brings up another topic that I know that you've been interested in, which is plasma energy and thinking about moving forward in this age of data and AI. And look, our country was energy independent while Trump was president the last time around. It's obviously gotten away from that. But the goal is to be energy independent again. And one of the races that every country's on the move for is AI, which is going to require an insane amount of energy to keep that going and to fuel that. So what is it like? What are some of the technologies that have been suppressed that we need to start using and moving forward? Whether it, we're talking about being open-minded and what could be and where we've been as human beings, but also what technologies are being held back that are holding us back, that are just sitting and waiting for us to use to sort of catapult us to the next level?
Well, that's a great question. And this is an area that's relatively new for me because it's only within the last 2 or 3 years I've shifted my attention to trying to understand, okay, if there was ancient civilizations, ancient cultures, and they were technologically advanced, first of all, let's not assume that they looked anything like we do. I mean, we built a whole civilization based on fossil fuels. Is that the only way to build a civilization? And I think the answer is no, it's not. I'm looking at our fossil fuel use as a very effective and powerful interim transitionary phase. But I think that there are technologies on the horizon that could be recoveries of things that people in the past already knew about. And we could get into, probably aren't going to have time in this episode, but to talk about what the evidence it would be that peoples in the past knew had technological, scientific knowledge that's been lost. And of course, referencing back again, the ability to move 20-ton stones with impunity. And that's only the icing on the cake. There's a lot more that we could get into that would suggest levels of scientific or technological sophistication that we've completely overlooked. Because for one thing, to use Barbara Tuchman's phrase of her book about the Middle Ages, which is called a distant mirror. But it's kind of like when a lot of the archaeologists are looking into deep history, which to me goes back beyond the Holocene. The Holocene is the last roughly 11,000 years, post-Ice Age. But when we're looking into deep history, we're really looking into a mirror. We're looking for something that looks like us, and it may not look like us.
Yes.
See, so that's part of the problem. That's part of
totally agree. I asked Neil deGrasse Tyson that even when it comes to like looking for humans. I'm like, another place, I'm like, but why should it look like us? Like we have like this narrow window of potential to being here. And it's like, man, it doesn't always need to look like us. Something doesn't always need to look the same.
What was his reply?
He said, we are made of the most common ingredients in the universe. So it is natural. It would be natural to look for something similar.
Well, yes, but how does that address the question of technological sophistication?
Sure.
Do we necessarily look for the kinds of expressions of a fossil fuel-based industrial civilization? Mm-hmm. That's, to me, a different question.
Mm-hmm. Yeah. Well, what do you think?
Well, I think that it's something I pondered for years, and now I think I'm kind of getting closer to an answer. And I'm still a little reluctant to talk about it and get into it in depth, only because there's a gap between what I've seen convincingly demonstrated and my understanding of what I'm seeing. But basically, it boils down to utilization of the fourth state of matter, which is plasma. Mm-hmm. And I'm trying to wrap my head around the science of plasma physics. It hasn't been my wheelhouse. I'm studied geology, stratigraphy, sedimentology, glaciology, astronomy, planetary geology, impacts, et cetera, et cetera. I haven't really studied plasma physics until the last couple of years when I've seen, well, this may be the link to an ancient civilization, at which point I begin shifting my attention. Okay, I got to learn about this. Okay, well, interestingly, around 9 years ago, I started getting calls from an inventor named Malcolm, a very controversial individual, and there's a whole backstory there. But he's brilliant, and I think he has rediscovered some crucial aspects of plasma physics. Now, he's built upon, there's a whole series of half a dozen inventors going back to Nikola Tesla that have touched upon this. I mean, Martin Fleischmann, if you look up the Martin Fleischmann Memorial Project, they're dealing with alternative energy, plasma energies, over unity, 0-point energy, all of this kind of stuff. Bostic, let's see, what's his first name? Bostic. Fleischmann and Pons were two of the big innovators. Ken Shoulders, Victor Schauberger, who you may have heard of him working with vortex phenomena in water. Write down Victor Schauberger, Schauberger, Schauberger. I think you'll find his work fascinating. Anyways, Malcolm had built upon all of these people's work, and I think he came up with some innovative insights. And basically, he came up with ways of using electromagnetic fields to control plasma energy. Plasma is the fourth state of energy after solid, liquid, gas, plasma. Solids, the molecular bonds are very strong. The atomic bonds are very strong. There's still atomic bonds between electron and neutron in water, but they're greater degrees of freedom, which are expressed in, if you have a solid, if I take a solid like this thing right here, well, it doesn't matter. I mean, I move it around and I set it down. It doesn't change shape. Mm-hmm. But if I take this cup, I can fill it with water and it assumes the shape of the cup, right? Because it has these greater degrees of freedom. If I add more energy, so if I add enough energy to this thing, it's going to melt.
Right.
It's going to turn into a liquid, right? Now it's got greater degrees of freedom as long as that energy is supplied. I add more energy to a liquid, let's say water, it evaporates. It becomes a gas. Mm-hmm. And so now it's free, to take any shape. In fact, it's not confined.
Yeah, it's not going to take the shape. It's going to keep moving.
Exactly. So, but what happens if you add more energy to that is you get a plasma. So now you have a separation of electrons and neutrons. Neutrons become ionized. You have this free flow of electrons and ions, and they're electrically conductive. Because they're electrically conductive, they're now susceptible to being affected by electromagnetic fields. So what this energy does is it uses that to cause the plasmas to cohere into a specific geometric form, which for whatever reason, and I don't understand, I don't have an explanation for this, the preferred affinity for a plasma is a torus shape.
Of course. They say we have the torus. Like, our bodies are have a
and see, field. This book, Robert Temple,
of Heaven,
A New Science of the Heaven, and it's titled here, the blurb at the top says, How the Science of Plasma Will Transform Humanity's Understanding of Its Place in the Universe.
Oh, wow.
It's very interesting. Here's the story of scientific research into plasma, the fourth state of matter. Robert Temple reveals extraordinary discoveries that up till now have been unknown by anyone outside specialist circles, despite the fact that many of the pioneers in this field have been Nobel laureates. The implications of these discoveries for our place in the universe, for the likelihood of other forms of intelligence out there, and for our understanding of human nature are extraordinary. So anybody who wants to dive into this more, read this. And it really brings up
my cup of coffee.
What?
Sounds like my cup of coffee.
Yeah, I think you'd enjoy it. And it gets quite speculative, but we're dealing with something here that invokes in my mind the famous saying by Arthur C. Clarke, when he said, any technology sufficiently advanced is indistinguishable from magic.
That's right.
And I think we're dealing with things in the realm of magic.
I've been obsessed with magic for like a year or two now, where I literally watch magic shows on TV because I believe it's real. I just don't know. I want to learn. In fact, I have you heard of Robert Gilbert?
Yeah, he actually took some of my workshops many years ago.
Okay. Well, he does biogeometry and some other things. But he also sort of studied the Rosicrucian order. And I was fascinated to talk to him about the magic side of it, about everything from how to move something with your mind to change the weather, like all of the things in the things in the realm of magic. And unfortunately, he ended up sort of telling me more about the integrity of why you would want to use it as opposed to the magic itself. I really believe all of what you just said is so true. And I've always believed that magic is just what science hasn't proved yet. And I've said that for years.
Well, yeah. So that
because we don't have any other word for it. We don't have any other word for it yet.
Yeah, and that's very consistent with what Arthur Clarke said. Wow. Any technology sufficiently advanced is indistinguishable from magic. And I think some of the stuff that I've seen now demonstrated with the plasma technology is quite mind-boggling. Like, what the hell's going on here? So I've been in rooms demonstrating some of the simplest applications of this technology, which would be like retrofitting generators or internal combustion engines. I can give you afterwards, if you're interested in looking in more, I'm going to send you some links of some of the things that I participated in. In fact, I just was in Florida on one of my travels down in Clearwater, Florida, just south of Tampa, with a group of people that have been working directly with the inventor, Malcolm, to try to bring this technology to the world. There's a woman down there. She's a big Trump supporter. I looked up online. I think she donated like $36 million to Trump's campaign. She's founded a museum called Imagine. And she is one of the things that she's doing there is she is putting in a major display of all these alternative energy kinds of possible solutions, including plasma-based energy. There's going to be retrofits of, I believe, my understanding is they're going to actually have generators there, and they're going to show maybe demonstrations of what can happen.
To take it from gas state to plasma state, what is the application to increase the energy? Heat?
Well, because the plasma generates energy.
Frequency?
Frequency, is that what you just said? Frequency? Yeah. Okay, so frequency is critical important to the whole functioning of the system. And here's what's interesting to me is that the frequencies that seem to cause these incoherent, free-flowing plasmas to self-cohere, to self-organize into these toroidal shapes are the frequencies to which they're subjected. Those frequencies, the numbers that represent those frequencies are straight out of sacred geometry. They're straight out of the dimensions and proportions and ratios that we find consistently in ancient sacred architecture.
Are they Hertz frequencies now, or are they like 432, 528, 639, 741, 8? Yes.
Okay, now
listen to all those. I sleep to those sometimes.
Good for you. See, okay, so those are literally at the core of this technology.
Oh, wow. Once the thing is about all this is like once you take chakras, colors, numbers, frequencies, and they all correlate over the top of each other, and they all complement each other. Yes. It's crazy.
Well, this is what the fact that these numbers recur so redundantly in these ancient traditions. They occur in the Sumerian writings, in the king lists. They recur in the Bible. They occur in Mayan traditions. They occur in the Vedic, ancient Vedic traditions of India. You know, the great yugas, the time cycles, the kalpas. So these frequencies seem to govern not only phenomena spatially, but also temporally in time. So that I wish I had it right in front of me. I don't know if, let's see if you can see it. maybe if I turn my camera here, let's see if I can do this without.
Yep.
Okay, right here. This is a dodecahedron.
Oh, okay.
It's got 12 pentagonal faces.
Is it crystal?
No, it's wood. I make
Wow.
these things. My team makes these in my shop. So I have a shop, so we make the compasses, we make things like this. And a lot of other things too.
The dodecahedron shape that you create, does it emit a frequency?
Well, here's the thing, so in this plasma technology, the control of the energy is based upon frequencies that can be determined by taking the sum of the internal angles of each vertex. So if you see that here, like around this, the inside angles and the outside angles are measured by the same numbers. Now, if you look at this pentagon, this is a pentagon, right?
The shape over your shoulder there on the desk?
Yes, right there. There's a vertex, a corner. Okay, so you've got a vertex there.
Yep.
Every edge, the edge angles on a pentagon are 108 degrees.
Mm-hmm.
So if you do 3 of those at each vertex, I'll go 108. Let's see if you can actually see this. Okay.
Yep.
Now, there's 3 of them, so I go times 3, and it's this.
Mm-hmm.
Okay, so now there are 20 corners, 20 vertices, so I multiply that by 20, and I get this number, 6480.
Okay.
Now, that's a very interesting number. Okay. Well, for one thing, if you multiply that times 4, and I'll go times 4, gives us this number. Well, that's the number of years.
Oh, the procession.
Yes.
It is.
Now, when you think of the processional wheel as the great year,
and
it's divided into 4 seasons,
right,
each symbolized in ancient iconography by the bull being Taurus, which is a fixed sign. I was informed that you've studied some astrology.
I have, yep.
You got bull, Taurus, the fixed sign.
Yep.
The lion is Leo.
That's right.
Fixed fire. The eagle is Scorpio. It's not actually Scorpio, but it marks the same time of year because Aquila, the eagle, rises with Scorpio. So if you're trying to define...
And that is 258. That is 2, 5, and 8 in astrology.
Okay.
Taurus is 2, Leo's 5, and Scorpio's 8.
Interesting. Okay.
I don't know if that means, but they're every 3 then.
Yeah. And then what's the last one? Aquarius.
If it would be 11 would be Aquarius, but Pisces is actually the last, which is 12.
But in the ancient symbolism, you've got the bull, the lion, an eagle, which is the substitute for Scorpio, and typically a man or an angel that represents Aquarius. So if you divide the cycle by 4, each of the seasons is 6,480 years. See? So this number now measures the dodecahedron, which was Plato's representative model of the universe, a dodecahedron. You now have this critically important number from the great cycles of the world year. And if you go double that, you get 12,960, which is within 1 century of the Younger Dryas. So one of the things I've done is looked at events in Earth history that would be catastrophic. And to a very large extent, they do correlate with the frequency numbers. And there's some really interesting stuff going on now in that realm. A young lady that I've met who's a frequency scientist named Sheila Rahman, I think it's Rahman, she's feeding these ancient sacred numbers into an oscilloscope and generating 3-dimensional forms. And it's really interesting stuff. And I'm going to have some of her stuff on my website. Well, at the end of February, I am holding a retreat, a introductory sacred geometry retreat at a place called Beersheba Assembly up on the Cumberland Plateau of Tennessee. It's a pre-Civil War, was a hotel. It's been restored, and it's up beautiful, overlooking a beautiful valley. It's got a very historical feel to it. I do a lot of conferences and presentations, and a lot of things. I just was down in Miami Beach at a hotel down there, and everything was just as fancy as you could get. But I actually feel more comfortable in something a little more, I don't know, say rough here. I'm rural. I grew up in the country. All our neighbors were farms. My dad was a carpenter. I'm just, more comfortable. And to me, this place was really comfortable. Great people running the place. So we've reserved it for 3 days, the end of February, and we're going to do a sacred geometry retreat.
That would be fascinating.
And it's going to be hands-on. We'll provide everybody with what they need, from everything from calculator like this to compasses like this. We're putting together, like when I've done these before, I'll put together like a tote bag, and all the supplies you need will be provided as part of the tuition. Because one of the things I learned was that if everybody had the same supplies, it really facilitated moving. And I have a lot of material I want to cover. So we start out, it's heavily on the drawing. And then we learn the basics, and then we start going into the other realms, like the symbolism that's associated with the numbers, and exploring areas where these forms are found. We might look at architecture. We might look at art. We'll look at, stuff in nature. I like to look at the structure of the solar system, for example, and show how we find these numbers embedded in the architecture of the solar system. So, like I said, it's heavy on the drawing. We're, going to make it affordable. I haven't done a sacred geometry retreat for a couple of years, so I was kind of feeling people were requesting that. And then we did a tour out of this place, the Beersheba Assembly, about a year ago, and it was great. They provided us the meals. They've got accommodations there. We've got we can do a big campfire and tell stories around the campfire.
Oh yeah,
build the camaraderie and the community of people who are very interested in these kinds of things. And a lot of the feedback I get from people is, well, we love learning about all of this stuff, but what we like just as much is all the new friendships and the interesting, smart people we're meeting who are into these. I have people telling me, some of the best conversations I've had in my whole life is when I'm doing these things with you. And I go, that's one of the reasons I do it.
Yeah, like-minded people sharing and expanding into areas that they're fascinated with. I mean, I love those. I love retreats too for that reason. You're showing up because you're interested, and guess what? Everybody else is too. So it allows you to just get lost in the fascination of the topic.
And I try to bring in. I encourage people, if they have kids that are interested, bring kids. I've had kids participate with adults, and it's very interesting because I've had kids as young as 8 or 9, and they have fun because they're, and then of course we provide colored pens and pencils because I bring into color. I said, we draw this diagram, and then, we color it because it really helps to fix in your mind what the forms and the shapes. Then we look at the numbers coming out of it. Now in an introductory, we're only dealing with planar geometry. We're not dealing with third dimensional like the dodecahedron. But then when I do an intermediate or an advanced course, then we go from 2 into 3-dimensional, and we learn those transitions from like a 2-dimensional system to a 3rd-dimensional. And that's when it gets really, to me, really interesting. And I think that emerging out of there could be a new architecture, an architecture of harmony that's, literally creates a world where, it really has an intimate connection with your physiology, with your emotional state, your psychological state. It's just the realm of beauty, because I think the beauty, there's actually a system that you can incorporate to enhance the manifestation of beauty. And I think ancient peoples understood that, and we're in these workshops, I'm trying to recover. So
I love that. I love that. As a builder, and then your area of fascination with ancient architecture and ancient how they did it, to then you're basically bringing them, both of those worlds together. I think that another person that actually talks a lot about beauty and the architecture that we have these days versus more ancient times is Tucker Carlson. He talks about that a lot, and how it's really sad what we've sort of the place that we've come to, and the world that we live in. There's no beauty in it anymore, and how valuable that is. And I think Jordan Peterson even talks about that too, with artwork and everything. It's like, it's true. There's some magic that we don't understand in the architecture and the symbolism and the sacred geometry. Someday I'd love to build a house. Maybe someday you can. Where I incorporate sacred geometry into not only the orientation of the house, perhaps where it is, but then also the shape of the house, the which direction, the ceilings and what they look like, all of those things. I feel like the future of homes is sacred geometry, so that you're creating frequency natural frequencies within the house that are healing. And maybe that's what they used to do in old times too. I mean, to me, I think that's something about, I think that that's actually what the pyramids were used for. I think they were a little bit more energy centers for something. I think that even have you heard of the place Integratron out in Joshua Tree? You've probably been there.
No. What did you call it?
Integratron, and it was
I'm not familiar with it.
It's a place out in Joshua Tree that there was apparently like a crash landing of an extraterrestrial. This information was gathered by these scientists, and they were taught and shown how to build something. So it's essentially this little silo that comes up, and there's these pins that can't come out all the way around. And originally it was supposed to spin. And as you pass through it, the negative ions would get rid of your disease that you had. Anyway, the story goes, told to me by John Paul DeJoria, who is Paul Mitchell and Patron. I don't know how he got involved, but he was telling me this story that fast forward till when they built it, they were the original scientist builder suddenly died and was contacted. So he was contacted by the doctor's wife, and she said, "Don't look into this. Don't come out here anymore. Don't ask." And so the last thing was to go there the next day. So he went the next day. They had already cremated the body from the day before. And basically, like it now it's turned into a sound healing place. So you can go and you lay in a little bed all spread around the outside of this round circle, and they play sound bowl music, and they go up all the chakras. There's one for each chakra of the body. So but I mean, these technologies that we just don't know about now, or don't use.
Yeah, we barely talked on that subject, and there's a whole lot more we can talk about. So we should probably do this sooner, do another episode, and not do it a year from now, but maybe before the year's out or early next year.
I'd love that.
Because I'd really like to catch you up on some of the stuff that I've been doing, like this trip to Florida with these folks, and the Imagine Museum. She actually is very tight with Donald Trump, and I missed her. She was in London, and then I came home, and she arrived the next day and met with the group that one of them was like the head of the Martin Fleischmann Memorial Project, brilliant physicist named Bob Grenier. So I got a 3.5 hour like coaching session from him that we recorded in plasma physics. Wow. And I'm now going to have to watch 50 times.
To get it all. That's how I feel with people like you and people listening. Like, I'll go back on that and listen to all of it.
But the next day, now I'm not sure where I think it was at Mar-a-Lago. She was going to watch the returns with Donald. And
well, one thing I heard that was really interesting, it's going to be way too big of a deep dive rabbit hole, but the Ark of the Covenant is something that I'm always very fascinated about, and that they apparently built an Ark replica, the box with the cherubs on top, and supposedly that was at Mar-a-Lago, or that was at Trump's house. Like, that box was there for a while, and even in the one
that.
Yeah. So,
So it seems like, okay, things are coming together here in an interesting way, because supposedly now at that meeting, Elon Musk was going to be there and RFK.
That would be a good idea.
And apparently I've been told that this lady is a fan of mine. So I'm thinking, I've got to put together a prospectus of what do we do with this information?
Exactly.
And it covers a lot of stuff that we haven't talked about. Jen yesterday asked me about, the whole UFO alien thing.
Yeah, we didn't even get to that.
No, I've avoided that deliberately for years.
Therefore, I have avoided it with you right now.
But I've just finished. You know this guy?
Lewis, no.
Lewis was former head of the Advanced Aerospace Threat Identification Program, the Pentagon unit that researched UFOs, now known as Unidentified Anomalous Phenomena. Whoa. So I made a comment on Joe Rogan about a year ago because he asked me about that, and I've avoided, even though I've looked into it and I have my own thoughts about it. He asked me and I said, well, there's this, maybe high performance aircraft testing is one part of it. Natural phenomena, anomalous things, because we know that nature can produce very interesting visual and auditory phenomena that many people see and don't know what it is. Then there's the idea of aliens but from where? Are they from other star systems? Are they from other galaxies? Have they learned how to transcend the light speed barrier? How have they done this? Mm-hmm. But then I just said, without going into it, I think that there's a fourth possibility that's been overlooked. And then Joe says, well, what is that? And I said, well, we don't really have time to get into it now, so we could save it for another conversation.
That's what you told him.
A few weeks later, I get a call from Lou.
Oh, man.
He said, what the hell are you talking about? So we kind of got into it a little bit, and I kind of laid a little bit of it on Jen yesterday. And
wow, damn it, Jen got that. Oh, you'll have to recap me, Jen.
Okay, so we'll leave it at this. Here's something to consider: that after reading Lou's book, it's pretty much, this thing has really happened. There is something going on in our skies. We can't explain it. Thousands of people, many of them very credible witnesses, have come forward. The Department of Defense has been suppressing this for years. Why? I'm not sure, unless, of course, they're wanting to reverse engineer some of the technology and then use it for defense purposes. Mm-hmm. But Lou has undergone a tremendous amount of flack because of the fact that he resigned his position because he felt like it was time to go public with this, that we need disclosure. People need to know what this is about. Yeah. And I 100% agree, right? There are connections there with the possible propulsion that they're using, which brings us right full circle back to the plasma energy physics. But here's the thing I'll leave you. Consider, and I'm not ruling out that we may be looking at aliens from other stars and so on. I'm not going to rule that out. But what we seem to be overlooking is this possibility. Maybe it's us. Maybe it's us.
Like future us?
No, I would say more like our cousins. I'll put it to you this brings into a whole nother rabbit hole. I shouldn't have even opened my big mouth. Because we would be here for another hour. But and I kind of knew I was on the right track about 10 years ago when it was proposed that by a group of scientists that, what we now know about our past and the reality of global catastrophes throughout history and throughout the time that we humans have been on this planet, what would we do to maximize the probability of the preservation of our civilization?
I built inner Earth.
You're on the right track. You're on the right track.
Dead off planet is another one.
that is the one, I think that's the one I think you'll find the most fruitful if you start exploring that.
Sure, but it's a lot easier to go inner Earth than it is to get off the planet. But look, if they had the ability to get off the planet, then you would. You would. That'd be number one if you could.
Depends on where you're going to go.
The moon.
Now, the obvious choice.
Is
the obvious choice. Yes. So people have been.
Okay, you want to know what other thing Neil deGrasse Tyson said when I interviewed him last time too? I asked him about the moon. Neil deGrasse Tyson.
Okay.
I asked him about the moon, and I'm always fascinated about that. Did we go to the moon? Did we not? And he ended up saying yes, and lost the technology. I'm like, that's ridiculous. How you lose the technology? And he just said it was too expensive. But he said we're going to go back to the moon, and it's going to be. He said it'll be basically a defense. It's a defense position to be in, where we'll be up there with basically like the army. That'll be like high ground.
See, I don't want to go that route.
Neither do I, but he made it sound like it was very certain that we were going to be beyond the moon.
Yeah. I mean, there was a famous German rocket scientist, Kraft, or Ricky, I think, I don't know how to pronounce his last name. He said, if God had not intended for mankind to colonize space, he wouldn't have given us the moon. Because the moon is the obvious port of departure for the exploration of the whole solar system. And what I'm going to advocate, and have been advocating now, is that we need to come together internationally. Number one, and here's another book that I recommend. Have you talked to, or do you know this guy?
Nope. Matthew Lohmeyer.
Lieutenant Colonel Matt Lohmeyer, who has written this book. He was 2006 graduate of the United States Air Force Academy. He began his active duty military career as a pilot, flying over 1,200 hours in the T-38 as an instructor pilot, followed by the F-15. After flying, he cross-trained into space operations and gained expertise in space-based missile warning. In October 2020, he transferred into the United States Space Force. He has 2 master's degrees, a master in military operational art and science, and a master in philosophy and military strategy. Currently, he is lieutenant colonel in command of a space-based missile warning squadron in Colorado, where he lives with his wife and children. He got booted because he wrote this book.
Wow.
Got booted out of Space Force because he wrote this book. And what he says here, as he points out here, Marxism's goal of conquest and the unmaking of the American military. Mm-hmm. So basically, it's a critique of the whole woke agenda that's been forced onto our military. And because he wrote this book, he was relieved of his command in Space Force.
Wow.
Retired to a remote area of Idaho. And he is a good friend of mine. Wow. Before COVID went down, he contacted me. He actually showed up at one of my projects I was building, called me. He said, I'm in town. I've watched your stuff. I'm a fan of your ideas. I was wondering while I'm here, could we get together? And I said, yeah, I'm building a restaurant. I gave him the address. He showed up. We had a great conversation. We've stayed in contact ever since. He was on stage with Donald a few weeks ago.
Really?
Yes. Now, there was, in fact, when early in Donald's first presidency, he met with like 40 or 50 base commanders of Space Force. Sitting at the head of the table, spokesman for Space Force was Matt Lohmeyer. So Donald had already made a connection with him. So now he was on stage with Donald a few weeks ago, and Donald said, I'm going to appoint you the head of a task force, and you are going to be investigating. We're going to revive Space Force. You're going to be reinstated, right? They spent like $40 million training this guy. Wow. He's like Top Gun. He's like that guy, So before COVID hit, he had set up, and we were going to organize a presentation that I went to Space Force and presented them ideas on planetary defense. COVID came, so that got sidelined. as COVID relaxed and the limitations started opening up again, Matt contacted me and said, "You still want to do that?" And I said, "Hell yes, man." So he's begun to put the pieces together to enable me to do a presentation to Space Force. And then the book came out and he got booed. So it never happened. Well, if we go forward, I've got a whole game plan that I've kind of been developing for literally several decades now. And it is about how do we transition from a vulnerable terrestrial-based civilization to an invulnerable cosmic civilization, and how do we do it in the next generation?
That's right.
That's the game plan. And how do we utilize these ancient technologies to accelerate that evolutionary process?
Oh my God.
That's where we could pick up the
Yes.
the thread of our conversation.
I
If you
love
want to go there.
I am in love with that conversation, and I think many, many, many other people would be. Randall, thank you. You are a good human being and generous with your time and your information.
Not too good, but mostly good.
Oh, well, that's what all the best people say.
Well, we won't get into my wild youth. So randalcarlson.com. People can find stuff. Let me see what else. Oh, rumble.com. I'm on Rumble now.
Awesome.
What else? Yeah, so it's Squaring the Circle podcast. And then maybe do you provide links?
Yep.
I see just some links to Jan or something.
Yep.
Good. Yeah, I will send you the links. People can find us because I'm very much now about disclosing as much as possible, opening up. If I can get in there, I know Tucker. I interviewed with Tucker. I don't know if you knew that or not. He contacted me. Yeah, I love the guy. And I have the greatest respect for him. And I didn't know how interested he was in all the kinds of things we've just been talking about.
He is very fascinated with extraterrestrials, with the potential of it, what that means. Oh, yeah. Yeah. No, you're striking at the perfect time. And I think that great things are going to happen and unravel and reveal themselves in the coming
I think so. And
6 to 12 months.
I'm optimistic.
Cool. Well, thank you so much. And I'll see you again very soon.
Absolutely.
Thanks,
Look forward
Randall.
to it.
Thanks, everybody, for listening to the Pretty Intense podcast today. I hope you enjoyed it. If you like what you heard today and you want to hear more, please click on the subscribe button.